Right, so in this video, we'll discuss the pure mathematics 3 for October-November 2024, paper 3-2. Let's start with question number 1. We are given a bracket with a power outside. They want us to expand this in ascending power of x up to and including the term is x squared, simplifying the coefficient. Alright, so for this one, basically it is a binomial expansion, right? Okay, so the formula basically is provided in the formula booklet, so you can have a look. So I will directly write out here as a reference, okay? So I'm having 1 plus x power n. The binomial expansion will be 1 plus nx, then plus n, then n minus 1 over 2 factorial, divided by x squared. So for this question, because they just want us to expand until x squared, therefore I will just show it here until this term. Okay, so if you want, you can continue further for x power 3, x power 4, and so on. But for this question, we'll just stop at x power 2. Okay, so to apply this formula, there's one small technique that you need to know here, one small detail. You have to make sure that the first term must be a 1. Then only you can apply this particular formula. Alright, so this is something that you need to take note of before you start. Right, so let's start with the question now. I'm having 9 minus 3x power half. Okay, so first of all, because we don't have the first term started with 1, right? It is a 9. So you can see it is a 9. I have to factorize out the 9 from the bracket so that the first term become a 1. When you want to factorize out the 9, you have to include the power as well. So you are having 9 power half. Then the 9, when you take it out, it become a 1. Alright, then for this one also the same, you have to factorize out the 9 from negative 3x, so it will become negative 3x divided by 9, where you will be having x over 3. So 3 divided by 9, you get x 3, right? 1 over 3. So this is what you get after you factorize the 9 from the bracket. Okay, so now if you double check again for this particular bracket, it is now started with 1. And your x is basically negative x over 3, and then your n will be the half. So we can start the expansion now by applying the formula. Okay, so square root of 9 is a 3. Okay, so I start now. First term for this bracket expansion should be a 1. So you just put it as a 1. The second term is n times x. So n is half. Power, right? Power is half. The n is the power, which is the half. And the x is the second term in your particular bracket. So the second term here will be actually negative x over 3. Plus, then the third term will be n, which is half. N minus 1, which is half minus 1, become negative half, divided by 2 factorial, multiply with x squared. So you're having negative x over 3, and then you square it. Okay, so just directly apply all the suitable number into the formula, and you try to rephrase it or simplify it by using calculator. So you're having this. Then continue further. So by right, your 3-term simplified answer should be something like this. Right? Yeah, so this is how we answer question number 1. Right, so question number 2, by sketching a suitable pair of graphs, show that the equation has exactly 1 root in this interval. Okay, so highlight the keyword pair. So you have to draw 2 graphs in the same diagram. So the first graph will be this one, where we are going to sketch y equals to cotangent to x. And then the other graph will be, we are going to sketch y equals to secant x. And then the domain that we are interested is from 0 until pi over 2. Alright, so again, if let's say you can remember or you can memorize the graph of cotangent to x or secant x, then you can go ahead. Then for me, I usually will need to do a little bit of relating with the original graph. So like for the secant x, right, the original graph is actually cos, where secant x is 1 over cos x. So what I need to do is like, I need to actually refer back to the cos x. Then I need to label all the important values. So this is pi over 2. Alright, and then when I want to draw 1 over cos x, 1 over cos x, right? From 0 until pi over 2, this is the part from 0 until pi over 2. Okay, I only want to consider this part. So when I want to draw 1 over cos x, the maximum point will become minimum. So maximum point become minimum means that Originally, this is a maximum point. This one here, the maximum point. All right, it become minimum. So become minimum means that your graph will go up from here. Right, then after that, this is 1, right? So 1 divided by 1, you get a 1. So it is started from 1, but it will be going up now because it should be a minimum point. So this is a minimum point, then the remaining of the graph should be going up. And then when pi over 2, at x equals to pi over 2, the y is 0. So you take 1 divided by 0, by right you should get the asymptote. So that means all the line pi over 2 now become the asymptote for 1 over cos, which is the secant. And then the graph will keep on going up, getting closer and closer to the asymptote, but it will not touch it. So this is how I sketch the secant x. So we are learning how to sketch the reciprocal function. For me, I can't remember the graph, so I have to use some method to help me, okay, to sketch it out. Alright, then after that we go for cotangent 2x. So cotangent 2x, the original graph basically is tangent 2x. So I need to sketch tangent 2x first. Then after that, only I try to convert it into 1 over tangent 2x. Okay, so I start to draw original graph first. Yeah? So this is the original graph for tangent x. Okay, original tangent x will look something like this. This is tangent x. But now I want to sketch tangent 2x. So to sketch the tangent 2x, right, all the value of x, I have to divide it by 2 or multiply with half. Because the stretch factor in x is actually the half, right? So you multiply all the coordinate of all this by half. Okay, so if I divide this by half, then I will have pi over 4. Oh, sorry, if I multiply all the x coordinate by half, I will have pi over 4 now. Because originally it's pi over 2. You multiply with half, therefore you have pi over 4. Same thing happened for this one. But if I sketch until pi over 4, right, it seems like my graph haven't completed yet. So what I need to do is that I need to continue to draw. The original graph from here until here is until, what's the value, yeah? Pi over 2, right? So after the pi over 2, 0, pi over 2, then originally it should be a pi. But now you need to multiply with half, so it becomes pi over 2. Okay, so that means for our tangent 2x, the original graph looks something like this. The purple color one. Okay, and now I want to convert this tangent 2x become 1 over tangent 2x. Okay, so how can I draw the 1 over? Alright, so originally you are having a 0 here, y equals to 0 here, and also y equals to 0 here. Okay, for these 2 points, okay, when you want to sketch 1 over 0, there will be a mass error, right? So it should be an asymptote. So that means this y-axis now will be the asymptote for 1 over 2x. Then at the line, x equals to pi over 2, it is also the asymptote for the 1 over 2x. Then at pi over 4, originally it is maximum. It is the infinity. It's a super large value here, right? This one also is a super small value, like negative infinity. When you take 1 divided by a very large value, so by right you should get a very small value, right? 1 divided by a very large value. So we assume that it is getting close to 0. It's a super small value, so we assume that it is a 0. Therefore, at pi over 4, the graph will cut through the y equals to 0. So this one. Okay? Then from maximum infinity to 0, then to negative infinity. So how I know that the graph here starts from maximum infinity? It is because of, on the original graph, the tangent 2x, right? In the first part here, it is at positive part. So when you want to take 1 divided by any positive value, it is still a positive value. Therefore, it comes from positive infinity. Then this one, it is below the x-axis. So 1 divided by a negative value, therefore you will get negative infinity here. But since this 2 line here is the asymptote, therefore when you sketch it, you will get closer and closer to the asymptote, but they will not touch each other. So this is our 1 over tangent 2x. This is our secant x. So let's combine them together in the same diagram. Alright, so this is the pi over 2. I will make it as asymptote here. and I'm having pi over 4. Okay, so I will draw my cotangent 2x first, yeah? So the cotangent 2x, the graph should look something like this. Okay? My one is not so nice, wait. Okay? And then this value should be pi over 4 lah. Okay, don't forget to label it. It should be y equals to cotangent 2x. Okay, then now I want to sketch secant x. So the secant x should be something like this. So maybe I can start from 1. The graph going upwards, getting closer and closer to the x-axis. Getting closer and closer to the line. X equals to pi over 2, but they will not touch each other. Okay, so assume this is asymptote lah, huh? Then you will be having y equals to secant x. So eventually, this is how your graph look like. Okay, but of course, if you can memorize the graph and straight away draw in the exact, it will be much more faster. If not, you have to do it like me. You have to find out all the details graph by graph, which might be a bit time consuming. Okay, alright, so after you sketch the diagram already, they want you to show that there's only one root in the interval. So to show one root in the interval, we are looking for the number of intersection point, right? Okay, so this one very obvious. You can see there's only one intersection point. So you just tell them that one intersection point can be seen. Okay, so therefore there's only one root in the interval. Because for the interval that we sketch the diagram, right, we can only see one intersection point. Therefore, that means in this interval, there's only one root for this particular equation. Alright, yeah, so this is what we have for part A. Then let's have a look for part B. For part B, they want you to show that a sequence of a real value given by the iterative formula, this one converge, that it converges to the root in part A. So you just need to rephrase this iterative formula and make sure that you can get back the original formula in part A. Then that means it is an iteration formula that can give us the root, right? Okay, so I start from the iterative formula. X equals to half tangent inverse cos x. Okay, so I try to rephrase everything here. So 2x equals to tangent inverse cos x. And after that, I'm having tangent to x equals to cos x. Okay, and after that, I take 1 over for both sides. So I'm having 1 over tangent to x, 1 over cos x. And this is how you get cotangent to x with secant x. So you just need to rephrase your equation and get back the original equation. Okay, yeah, so this is how we solve question number 2. Alright, so question number 3, they are talking about the square root of 6 minus 8i can be expressed in the Cartesian form of x plus iy. So x and y are real and also exact. So by first solving a quadratic equation in terms of x or y, find the square root of 6 minus 8i in exact Cartesian form. Okay, so for this question, basically, in short, they want us to find out the square root of 6 minus 8i. And the answer must be in the exact value. Okay, right. So to get the square root of 6 minus 8i, we know that the final answer that we get, it is still a complex number. The square root of complex number is still complex, right? So I will let it equals to x plus yi. So that means the x plus yi is actually my square root of 6 minus 8i. Right, so to get the x and y, I need to square the equation both sides. And after that, we try to expand it. Okay, then you should know that I squared basically is -1, right? So you will be having x squared minus y squared, then plus 2xyi. Okay, then now until this step, we need to compare the real part with real part, imaginary with imaginary part. So as an example, our real part for the left hand side is a 6, and I will want to compare it with x squared minus y squared. Right, so from here I form the first equation, x squared minus y squared equals to 6. So this is the first equation. Right, Then after that, the second equation is we are going to compare the imaginary with imaginary part. So you can see from here, negative 8 will be equals to positive 2xy. So this is the second equation that I can get. So I will put 2xy equals to negative 8. So from here, y basically is negative 4 over x. And this is my second equation. And of course, to get the answer right, you have to solve the equation simultaneously. Right? Okay, so how to solve the equation simultaneously? You can sub second equation into the first one. Okay, so you'll be having x squared minus negative 4 over x squared equals to 6. And try to bring in the bracket, so bring in the square, so you're having 4 squared, which is 16. And then after that, you're having x squared. Okay, then equals to 6. And now I want to get rid of the x squared at the denominator. I multiply the whole equation with x squared. And I try to rephrase it a little bit. And you can see that after I multiply the x squared for every single term in the equation, and also I try to rephrase everything to the left hand side, this is what I can get. And you can see very clearly that it is a quadratic equation in terms of x. So that means we are in the correct direction, because for this question they did hint us actually by forming a quadratic equation. So that means we already successfully get a quadratic equation and we are on the correct track. Okay, so let's continue. This is a quadratic form equation, so basically you can try to factorize it. I'm having x squared and x squared here. Then to get a 6, I should have 8 times 2, which is 16. Then I want to have minus 8 and positive 2, so that I get negative 6. Okay, so x squared equals to negative 2, where I think very obvious I have to ignore this part, because in the question they did mention that x must be a real number. Okay, then x squared equals to 8. And for x, by right you should have plus minus square root 8. So square root 8 you can further simplify, become 2 sub 2. Alright, and next, once you get the x, try to get the value of y. Okay, so when x is equals to 2 sub 2, what do you get for the y? You can substitute back into the first or second equation, but for me, I will strongly suggest you to substitute into the second equation. Okay, so the reason is because of it is more direct. If you substitute into something with a square again, later when you take square root, you will have two answers again, and you have to double check which answer is the correct one. So to be more straightforward, right, always consider the linear or maybe the equation with power 1. Okay, so like this one, this is not linear, but it is at least everything with the power 1 in x and y. So I substitute into the second equation. So put the 2 inside, so 4 divided by 2 square root 2. So you're having negative 4 divided by 2 sub 2. And then I need to rationalize it. If you are not using ES calculator, or you are using still MS calculator, then you have to rationalize it by yourself. Okay, so 2 sub 2 is a 2. So 2 divided by 2 is a 4. So can simplify with the 4. You're having a negative sub 2 eventually for the y. Then for the x also the same. Substitute into the into the second equation. So you're having negative 4 divided by negative 2 sub 2. Then again, if you want, you can rationalize it. If you are using ES calculator, you just directly press answer. The calculator will give you the final answer in the third form. So this one will become a positive sub 2. Alright, therefore, rewrite your final answer again. The square root of 6 minus 8i, there are two answers here. The first one is 2 sub 2 2 sub 2 minus sub 2i, square root 2i. Another answer will be negative 2 sub 2 plus sub 2i. Okay, so basically this is how we actually get the square root of 6 minus 8i. Question number 4, they want us to solve this equation, then answer in 3 decimal places. Okay, alright. So now, 5 power x equals to 5x plus 2 minus 10. So how can we solve this equation? Right, so first of all, I can see there's a general term which is 5 power x. Okay, 5 power x, and then I'm also having another 5 power x somewhere here, right? Okay, so to solve it, I will prefer to group all the 5 power x together. So before I can group them together, right, I have to make it as 5 power x multiplied with 5 squared and minus 10. Okay, so you need to know from here to here, right, from first step to the second step, we are using some basic properties in indices, where you should know that when I'm having a power m multiply with a power n, then I can simplify it by using the power m plus n. So for this step, we are using the other way around. We are doing it backwards. So that means I'm having 5x plus 2. I separate, become 5 power x multiplied with 5 power 2. Okay, so 5 power 2 is a number. So 5 squared is 25. Multiply with 5 power x. Okay, so continue from this step. If you can see the 5 power x as an object, then you can simplify them. If let's say you cannot, you can let y equals to 5 power x first, so that you can see the equation in a clearer way. If you let y equals to 5 power x, right, so you'll be having y equals to 25y, then minus 10. It's very obvious, right? It is a linear equation actually, right? So you'll be having 24y equals to 10. Okay? And from here, you get your y equals to 10 over 24. So 10 over 24 should be 5 over 12. But of course, this is not your final answer, right? Because your final answer should be in terms of x. So replace back your y into the 5 power x equals to 5 over 12. So we take ln both sides and pull the x in front. Okay, then after that, to get the value of the x, I have to bring the ln 5 over. And try to use calculator to help us and simplify the answer. So by right, you should be getting a long answer here. And after that, don't forget to correct it to 3 significant figure, which is 0.544. Alright, so this is how we get the answer for part 4, for question number 4. Alright, so question number 5. We are given a complex number u, and this is what we get for the u. Alright, then find the exact value of argument u, exact value. Okay, so to get the answer for this question, right, I think there are more than one method to solve it. Alright, so let us discuss both of them. Okay, so for me, right, personally, when I look at this particular question at the first sight, I realize that there's a denominator, there's an I in the denominator. So usually when we are having any complex number with I, right, at the denominator, the complex number at the denominator, we will want to rationalize it so that the denominator disappears, correct or not? So I'm doing the same thing actually here. Alright, so first I will try to rationalize it first. Okay, so I'm having cos power pi, cos pi over 7 plus I sine pi over 7 power 4 divided by cos pi over 7 minus I sine pi over 7. Because I want to rationalize it, so I need to multiply it with the conjugate of the denominator. So the conjugate of the denominator is cos pi over 7 plus I sine pi over 7. Then same thing happen on top. You're having cos pi over 7 plus I sine pi over 7. Okay? Then next, let us simplify it. Okay, so I'm having cos square at the bottom. Then plus sine squared minus sine squared I squared. Sorry, maybe I should put minus first, yeah. So I will be having minus I squared, then sine squared. If you try to expand term by term, after I simplify, this is what I get. Then on top, I will be having cos pi over 7 plus I sine pi over 7 power 5. Agree or not? Because this and this are the same. This one and also this one are the same right on top. So you will be having power 5 now. Okay, since just now we know that we are having the negative I square, and the negative I square is a negative 1, right? Sorry, I square is a negative 1. So when you try to simplify your term now, it will become something like this. You'll be having cos square plus sine square. So what's the value for cos square plus sine square? When you're having any angle, right? Same angle, cos square theta plus sine square theta, basically it is equals to 1. So your u is actually this complex number, cos pi over 7 plus I sine pi over 7. Okay, all right. Then now, because they want us to find the argument for the u. So to find the argument of u, it is a complex number with power 5, which looks like very complicated. But actually, let's have a look for the complex number without the power first. Okay, so for cos pi over 7 plus I sine pi over 7, right? It is basically the modulus argument form where in front you have a 1. This is something like your R, modulus argument form. So R cos theta plus I sine theta. And when you are having the modulus argument form, right, you know that the modulus is a 1. And directly all the angle inside here is the argument. So for this particular complex number, the argument is actually argument of this, but it is not the u, because u is with power 5 one, right? So it is the argument. So the argument for this one is actually pi over 7. Okay, and then to get the argument for u, because we are having a power 5, so I think we did learn a shortcut formula before, or concept before, yeah? When you are having u, let's say you're having the complex number u multiplied with w, right? Okay, to get the argument of u multiplied with w, you just need to add them together. So argument u plus argument w. Okay, so if you are having u square, so that means it is actually a u times u. So you'll be having argument u plus argument u, which is equals to 2u. So the same concept continues. If let's say I'm having a higher power u power 3. So u power 3 means u times u times u. So to get the argument, it will be argument u plus argument u plus argument u, which is 3u. So I'm having this complex number power 5. So to get the argument of u, you have to take this argument multiply with 5, or pi over 7 plus pi over 7 plus pi over 7 for 5 times. So eventually, your final answer for the argument u will be 5 pi over 7. Okay, so this is basically the first method to get the argument of u. Alright, yeah. So let's have a look and see whether we got a second method or not. The second method, how are we going to solve it? Okay, so the second method, basically I refer to marking scheme, and this is what suggested by the marking scheme. Okay, so now, previously we did also learn the concept similar to what we learned just now, right? So if let's say you're having argument u divided by w, if you're having like the complex number u over w, two complex number, on top is a complex number, at the bottom also complex number. So argument u over w is equals to argument u minus argument w. Okay, all right, so for marking scheme, they are using this concept, right? Where if I want to get the argument u, okay, so I assume that I'm having two complex number, one complex number on top Wait, yeah, I rephrase it first nicely. Okay, so divided by one complex number at the bottom. Okay, then let's have a look for the complex number on top. I only want to refer to this one. So like what I told you just now, right? When we are solving the question earlier. So for this one, without the power 4, I know that for this particular complex number, the argument is a pi over 7. Okay, so if let's say I put a power 4, okay, that means the argument will be pi over 7 times 4. Like what we did for the 5 one, power 5 one, right? So it will be pi over 7 times 4. So this one settled already for the argument on top. So the argument on top will be pi over 7 multiplied with the 4. Let's have a look for the argument at the bottom part here. To get the argument right, directly from the pattern of the modulus argument form, you have to make sure that this sign in the center is always a positive. It cannot be a negative. So that means I have to move this negative, go back. Okay, so you are having cos pi over 7 plus I sine negative pi over 7. But if you want to make it as a modulus argument form, the other detail is the argument, the angle inside the cos and inside the sine should be the same. So if let's say the sine must be having negative pi over 7, then the cos must be also having negative pi over 7. And if you try to double check again, if you put the negative here, will it affect our answer or not? So you realize that cos negative pi over 7 is actually still equals to the value of cos pi over 7. Okay, so this particular complex number at the denominator is actually this one. Originally it should be this one, but after simplify, you get the purple color one. Okay, alright, so from here again, if I want to have a look for the argument here, so what's the argument for this part? So the argument is actually negative pi over 7. Okay, so again, the argument on top is pi over 7 times 4 because it is power 4, so you have times 4. Okay, then for the bottom one, after you rephrase it, you realize that actually the pattern should be cos negative pi over 7 plus I sine negative pi over 7. And therefore, I get the argument equals to negative pi over 7. So to get the argument u, we want to use the idea where the argument on top, which is 4 pi over 7, divided means minus the argument at the bottom, so minus pi over 7. So if you add them together, by right, you will be having 5 pi over 7, which is still the same answer with the previous method that I used. Okay, so I don't know which method to use is easier to understand and easier to think about to start with. For me personally, I start with the first method that I showed you just now. Okay, and then if you're able to know how to rephrase your modulus argument form correctly, then this method should be shorter. And this method is suggested by the marking scheme, okay, from Cambridge. Then this is what I can think about, okay, when I look at the question at the first sight. Alright, so let's have a look for the marking scheme. Because I think if let's say you are aware, right, in the marking scheme, they did put in some remark. Okay, so they did put in some remark. This question only given 2 marks. So the first mark, right, basically they want you to show that you are using this or this one. Okay, then they said many multiply top and bottom by the conjugate, which is that something that we are doing now in the first method here, right? Because I multiply top and bottom by conjugate, which is fine. But to score the method number 1, you need to state the argument of a complex number. So that's why if you are using this technique, right, in your particular step, you have to state the pi over 7 because pi over 7 is one of the argument. It's actually the argument. After that, you take the argument, only you multiply with 5 to get the final answer, right? Multiply with 5 because of the power 5. Alright, so the original argument is actually pi over 7. So in your solution, you have to show and state the particular argument, which is pi over 7. Then only you can get the method 1 mark. If not, you might only get an answer mark. Okay, so that's why I have to take pi over 7 multiply with 5. Okay, so I will get 1 method mark here, then final answer. Okay, all right. Yeah, so this question to me, I think is a bit not so straightforward, I would say. All right, so please take note on this. Okay, right, so let's have a look for part B. Now they said the complex number u and also u conjugate are plot on Argand diagram. Describe the single geometrical transformation that maps u become u star and state the exact value of the argument u. Okay, so just now we already know that the argument u is actually 5 pi over 7. So maybe we don't talk about the original complex number here. We talk about the basic u first. If let's say I'm having the basic u, right, it is actually x plus yi. Then when I want to get the conjugate, it should be x minus yi. Okay? Understand? Because we changed the sign here. If you have a look for argument u, it is 5 pi over 7. That means if I try to sketch the diagram for the u, the complex number on the Argand diagram, if let's say this is the x-axis, how will your u look like? So 5 pi over 7 tells you that your complex number u is in the first quadrant. Agree? Okay, so when you want to sketch the complex number u in the first quadrant, this is how you sketch it. So this is a u. I don't know what is the length because I didn't find out, but I know that the argument is basically 5 pi over 7. Okay, so this is 5 pi over 7. If your u is in the first quadrant, just like x plus yi, when you want to sketch the conjugate, it will become x minus yi, right? So your x minus y, your conjugate will be somewhere here. This is x, and then by right, your complex number, the conjugate should be negative y. If this is positive y on top, then the negative y should be somewhere here, and this will be your u conjugate. So they're asking for a single means one, transformation that change the u become u star. So very clearly you can see that it is basically a reflection, right? You reflect the u through the x-axis. Alright, so reflection u through the x-axis, where the x-axis is a mirror, and that's why this is how you get the u conjugate. And what is the argument for the u conjugate? So the argument of conjugate is this one. The angle should be the same. If let's say you're having the reflection, so the angle should be negative 5 pi over 7. Okay, alright, so let's write it out. Okay, so the transformation is reflection in x-axis. Then what is the argument of u star? So the argument of u star or u conjugate should be equals to negative 5 pi over 7. Okay, so this is what the question wants us to write. Okay, so don't forget about the diagram. Okay, then reflection, the transformation, and also the argument for the u conjugate. So this is how we solve question number 5. Okay, so we are now at question number 6. We are given the variable x and y satisfy the equation a y equals to b power x. A and b are the constant, so the graph of ln y against x is a straight line passing through the point. So these are the passing point. And as shown in the diagram, find the value of a and b, give each value correct to one significant figure. Okay, so the original equation is this one, right? ay equals to b power x. So what are we going to do is like, we try to convert it into a linear equation first, because from the diagram given, right, it is a linear equation. Linear line is a straight line, right? So I have to convert it into a linear equation. How can I convert this curve into the linear equation? So basically we have to use take ln both sides, okay? So at first I try to make it in this way first, where y equals to bx over a. Then I take ln both sides. I'll be having ln y equals to ln b power x over a. So you know that ln A over B can be written as ln B minus ln A, something like that, right? So you have ln Y equals to x ln B minus ln A. Okay, I try to compare this one with our linear equation where y equals to mx plus c. And then you need to know how to compare them, right? You should know that your y-axis are ln y. X-axis is the x, which is true because you can see we are having ln y in y-axis, x in x-axis. This is the reason why you can get the linear equation, a linear line, because of the straight line, because of the linear equation here. So if you have a look from this one, the point provided, right, is basically the x coordinate is still the x. Then the 2.2524 here, right, the y coordinate by right is the value of ln y, because we are having ln y in y-axis. So to get the value for A and also the B, maybe what we can do is like we substitute the point into the equation. Then from there we solve simultaneous equation. Okay, so as example, for the first point, your x is 0.5, your ln y is 2.24. So substitute into the equation, ln y is 2.24 equals to x, which is 0.5 ln b, then minus ln a. Okay, so I get ln a equals to 0.5 ln b minus 2.24. And this is my first equation. And at the second point, I'm having 3.40 and also 8.27, right? So again, the 8.27 is the value of ln y. So 8.27 equals to x. X is 3.4, then ln b minus ln a. So from here, you will get your second equation in terms of a and also the b. Okay, then next, kindly solve the equation simultaneously. Sorry, I think I have to move it down because more spacious. Right. So let's move the solution to the space provided. Okay, yeah. So this is what I have for now. Then I want to solve them simultaneously. So 1 is equals to 2. Therefore, 0.5 ln b minus 2.24 equals to 3.4 ln b minus 8.27. Okay, so by right from here, you will get 2.9 ln b equals to 6.03. Rephrase your answer and get a b. B should be e power 603 over 290. So from here, you get your value of b, which is equals to 8. Correct to one significant figure, right? So if let's say I try to make it into one significant figure, it should be 7.9999 something. So I have to change it become the 8. Alright, then after that, you can get the value for a. So ln a is equals to 3.4 ln b. So ln b, I will substitute it as 6.03 over 2.9. Okay, then minus 8.27. So try to get the value of a, which is e power negative 3481 over 2900. Okay, then from here, my a, if I correct it to one decimal place, it should be 0.3. Wait, yeah, they're asking for one decimal place or one significant figure. Oh, sorry, one significant figure. So 8 will be the one significant figure. Then the one significant figure for a should be 0.3, the 3. So this is how we get the value for a and also the b. Okay, so the beginning part of this equation is you basically, for this question is basically you need to convert them into a linear equation first. Okay, then after that only you can solve it by forming the two equations from the points provided. Then you solve them simultaneously. Alright, so this is how we solve question number 6. Alright, so let's discuss question number 7. we are given the equation in terms of tangent x and also tangent 2x, then they want us to express it become this pattern. Right, so if we try to compare these two equations, right, the difference is you are having the tangent 2x in the original equation, but there's no more tangent 2x after you try to rephrase everything. Okay, right, so very obvious, I think we have to apply a double angle formula for the tangent 2x so that it becomes tangent x. So just to recall back, what is the formula for double angle formula for tangent 2x? So again, it is provided in the formula booklet. Therefore, if you need, then just have a look from the formula booklet. Alright, so the tangent to x, the formula should be 2 tangent x divided by 1 minus tangent square x. This is what we are going to use in this question. So let us start. I'm having this as original equation. Okay, so replace the tangent 2x by using the double angle formula for it. Okay, so next one, I want to get rid of the 1 minus tangent square x in the denominator here. So I multiply every single term with 1 minus tangent square x. Okay, so simplify the term. Simplify, maybe you can expand and then try to simplify every single term here in the equation. Right, then what do I have here? I will be having negative tangent power 5, then plus 3 tangent x, then 2 tangent cube x equals to 0. And then if I try to factorize out the negative tangent, then by right I'll be having positive tangent power 4, and then minus 2 tangent square, and also negative 3 equals to 0. Right, so when we are trying to solve this equation, right, so you'll be having negative tangent x equals to 0, and also this one. Right, so I'm having negative tangent x equals to 0. And also I successfully get the equation that they want us to show when we try to expand and also simplify everything here. Right, so if you have a look, this is basically the equation that they want us to show, right? Okay, so this is what we have for part A. Then let's continue to part B. For part B, hence, they want us to solve this equation for 0 until pi for the data. Give your answer in the exact form. So please highlight the keyword exact form. So your answer should be in the pi form or maybe third form. Okay, right, so if I try to compare this equation, right, with the previous equation, they have actually changed all the x become 2 theta. So this is my original question in part A. 2x then minus tangent x equals to 0. So if you try to compare the question, right, they have actually changed all the x become 2 theta. So x become 2 theta, therefore 2x become 4 theta. That means if you want to apply the result in the first part, you also have to change all the x become 2 theta first. So my original answer in part A, right, so we are having tangent power 4x minus 2 tangent square x, okay, then minus 3 equals to 0. So in this question, since they have replaced the x by using all the 2 theta, so we also replace our x into the 2 theta. We can directly prove it, we can directly apply the formula that we successfully proved, the equation that we successfully proved in first part directly, okay, but just that we need to change the x become 2 theta. Alright, so after I have change the x become 2 theta, this is actually a quadratic form equation in tangent. Alright, so you can try to factorize it. And then I will be having -3 and also +1. So I'm having tangent square 2 theta equals to -1. Then tangent square 2 theta equals to 3. Okay, then this one I cannot take square root negative, right? So I'll ignore it. There's no solution from this part. And after that, for this one, I will be having tangent 2 theta equals to plus minus square root 3. And for this equation, the basic angle for tangent inverse square root 3 should be equals to 60 degrees. So 60 degrees by right should be pi over 3. Okay, alright. So this is my basic angle. And we are looking for the quadrant with tangent plus and minus. That means I have to go through all the 4 quadrants. So maybe you ask why I need to go through with all the 4 quadrants, because they're asking for theta is between 0 and pi. But when you are trying to solve this equation, right, we are looking for the answer of 2 theta first. So if let's say I want to get the answer for 2 theta, it should be from 0 until 2 pi. That means I have to consider all the 4 quadrants to get the answer for 2 theta first before I simplify it to the final answer. Okay, so to get the quadrants with plus and minus sign for tangent, I have to consider all the 4 quadrants. So first quadrant is pi over 3. Therefore, the answer is basic angle. Second quadrant, the answer is pi minus pi over 3, or pi minus the basic angle. So maybe I should write it out. So it should be pi minus the basic angle. Answer in the third quadrant should be pi plus basic angle. Fourth quadrant, the answer should be 2 pi minus the basic angle. So this is what we learn, right? In different quadrants, how are we going to get the correct answer from each quadrant, right? Then you should try to simplify them. So by right, you'll be having pi over 3, 2 pi over 3, and then 4 pi over 3, and also 5 pi over 3. Okay, then of course, our final answer should be in terms of theta, not the 2 theta. So I divide every answer by 2. So I will have pi over 6, pi over 3, then 2 pi over 3, and also 5 pi over 6. So these are the answer for this question number 7. Alright, so question number 8. We are having the parameter equations of the curve, yeah? So we are having these two equations here. They want us to show that dy dx is equals to this answer provided here, right? Okay. So let us start. For the parametric equation, before you can get the dy dx, we have to differentiate the equation separately first. So I'm having tangent 2t and then square for the x. So to get the differentiation of x, which is dx dt, power I put in front, copy the bracket, power minus 1 become 1. Differentiate the thing inside the bracket, differentiate tangent, I'm having secant square. Then after that, differentiate the 2t, I get a 2. So to simplify this equation, I should be having 4 tangent 2t and then secant square 2t. Okay, then after that, at the same time, I have to differentiate the y also. So y is equals to cos 2t. To get dy dt, differentiate the cos first. So I make an error here, right? Here should be dt for dx dt. So now I'm getting dy dt. So differentiate cos, I should be having negative sine. Copy the angle. And after that, differentiate the 2t. Differentiate the angle, I get a 2. I'm having negative 2 sine 2t. Alright, so how can I get dy dx from the parametric equations? So to get the dy dx, I have to apply the chain rule, where dy dx can be get from dy over dt multiply with dt over dx. So what is my dy over dt? So dy over dt will be negative 2 sine 2t. Then dt dx is actually 1 over 4, then tangent 2t, and also secant square 2t. And let us further simplify it. So in the final answer that they want us to show, you can see that there's no tangent, right? And there's no secant. So we try to simplify everything by using the sine and cos. Okay, so I try to just remain the negative 2 sine 2t first. Okay, so for this particular part here, tangent 2t is 1 over tangent 2t. Therefore, you should be having cos 2t divided by sine. Because 1 over 2t, 1 over tangent 2t is that cotangent, right? So cotangent should be cos over sine. Then 1 over secant square. Secant square by right is 1 over cos. So you're having cos square 2t on top. Okay, then I think it's quite obvious. You can try to simplify all your terms here. Okay, sine 2t and sine 2t can be cancelled off. And from here, we successfully get what they want us to show already. So it should be negative half. And then cos power 3 2t. Alright, yeah, so this is how we get the dy dx for the parametric equation. So let's continue to the next part. For part B, they want us to find the equation of the normal of the curve. Equation of normal to the curve at the point where t is equals to pi over 8. Give your answer in the form of y equals to mx plus c. So the equation of normal, right? First of all, I still need to find out all the related information such as the gradient of normal. And then we need to find out also the passing point, right? Get all the coordinate of x and also the y. So let us start with t equals to pi over 8. When t is equals to pi over 8, I want to get the value for the x first. So what's the value for x? So x is equals to tangent square 2t. So tangent square 2t, I will get pi over 4. So tangent pi over 4 is a 1. So when you take 1 square, it is still a 1. After that, you also need to get the y coordinate. So how to get the y coordinate? The equation is cos 2t. So 2t is pi over 4. In this case, when t is equals to pi over 8, right? So 2t means pi over 4. What's the value for cos pi over 4? It should be sec 2 over 2. Then after that, I got this passing point already. The x and y coordinate. I also need to have the gradient of tangent first, which is dy dx. It should be negative 1 over 2 cos cube 2t, right? Okay, so cos cube 2t. So it should be cos 2t, which is pi over 4. And then you should be having a cube outside. Simplify the dy dx here. So by right, you should be having sec 2 over 2, then cube. Okay, so simplify further. By right, you should be having negative 1 over 8 sec 2. And you need to know that this is actually the gradient of tangent. But in this question, they are asking us to find the equation of the normal. So we have to recall back a little bit relationship between the normal and also the tangent, right? So what is the relationship? Normal and tangent, they are perpendicular to each other. Therefore, the gradient of normal multiplied with the gradient of tangent should be equals to negative 1. Okay, so gradient of normal multiplied with the gradient of tangent, which is negative sec 2 over 8. You have negative 1. If I try to simplify, the gradient of normal should be equals to 8 over sec 2. Okay, then I think I have to rationalize it. I don't like to have the denominator with the sec. Okay, so if I try to simplify it, I will be having 4 sec 2. Alright, so now I'm having all the information that I need now to form the equation of normal, where I need the gradient. So this is the value of the gradient. I need the passing point, where the coordinate of x and y is the passing point of that particular normal equation. Right? So since I have everything, so I can start to form the equation. So equation of normal is what? It should be y minus y1. So your y1 is sec 2 over 2. Okay, equals to m. M is gradient for sec 2. And then x minus x1. So the x1 is a 1 here. Okay, so we try to rephrase everything. For sec 2x minus for sec 2 plus half sec 2. Okay, then we can further simplify them. Okay, so the third two you can treat it like an apple. So you're having negative 4 apple plus half apple. So negative 4 apple plus half apple, by right you should be having 7 over 2 apples. So basically this is what we have for the equation of the normal in a parametric equation. So this is how we solve question number 8, right? Alright, so now we are at question number 9. We are given 3 position vectors for the point A, B, and C. And then they want us to find the position of D in part A. And of course they give us some information about the point D. So the point D is such that ABCD is a trapezium with DC equals to 3AB. Okay, so that means DC is longer, AB will be shorter, and then the DC is equals to 3AB. Alright, so to get the position vector of D, right? So I might assume that the position vector of D is XYZ. This is 3-dimensional vector, right? So I will assume that it is XYZ. Okay, so I will start by using the information provided in the question where DC equals to 3AB. Okay, so what is the DC? So DC means DO plus OC. DO will be negative X, negative Y, and negative Z plus OC. So what is the OC here? It should be negative 3, negative 2, and also 2. Equals to 3AB. So 3. I'll be having AB. AB means AO plus OB. So AO means negative 2, negative 1, and also the 3 plus OB. So what is the OB here? 0, 4, and also 1. Okay, so I try to summarize my vector on both left hand side and also the right hand side. Left hand side I'm having negative X minus 3, negative Y minus 2, negative Z plus 2. Okay, then equals to right hand side, negative 2 plus 0 is a negative 2 times 3. So you're having negative 6. Okay, then negative 1 plus 4 is a 3. 3 times 3 you get a 9. 3 plus 1 is a 4. 4 times 3 you get a 12. Okay, then after that I compare X with the X component, Y with the Y component, and also Z with the Z component to get the value for X, Y, Z. Right, and after that you can get the position vector of D. So I'm having negative X minus 3 is equals to negative 6. Therefore your X is equals to 3. For the Y, negative Y minus 2 equals to 9. So what is the value for Y here? Your Y should be equals to negative 11. Then I'm having negative Z plus 2 is equals to 12. Right, so my Z should be equals to negative 10. So this is the value for my X, Y, and Z, where the X, Y, and Z, earlier I already defined it as the position vector of D. So OD can be written as 3, negative 11, and also negative 10. Right, so this is how we get the position vector of OD. Okay, so let's continue to the next part, part B. So part B, they are saying that the diagonal of trapezium intersect at the point P. So find the position vector of P. Now they want us to find the intersection point. Okay, to find the intersection point, if let's say like this is a 2-dimensional vector, right? You can still form the Cartesian equation for 2 lines and then you try to solve that. Okay, but too bad this is a 3-dimensional cases where I'm not able to form a Cartesian equation to solve the intersection point or to find out the intersection point. So what I need to do is like, wait me for a while. AB, then maybe C. Okay, let us try to imagine first, yeah. Let's say this is C and D, like it is a trapezium. The trapezium that I draw here might not be correct one. Okay, I just want you to visualize something. Okay, they said the diagonal of trapezium. So that means you're having A to C is a diagonal. Then B to D is another diagonal, right? And their intersection point is a P here. So to find this intersection point for 3-dimensional cases, I actually want to form vector equation of BD, and after that I want to form the vector equation of AC, then I solve them simultaneously. So this is what we plan, okay, in solving and get the intersection point, alright, for the vector. Okay, so you have to form two vector equations. The first one is vector equation of DB, another one is the vector equation of AC. Then you solve that, right? So again, the trapezium that I draw here might not be a correct one. Okay, right. So let us have a look for the line DB first. So to form vector equation for the line DB, I need the direction. So the direction of the line DB will be DB or BD also can. Okay, so DO means -3, then 11 and also the 10 plus OB. So what's the value for OB? OB should be 0, 4 and also 1. Alright, so by right, your DB should be -3, 15 and also 11. Then I want to form the vector equation of DB. So the general formula for vector equation, what is it? So remember, it should be R equals to passing point A plus TP. P is the direction of the line. T is a constant that we don't know yet. Alright, so R equals to A plus TP. So to form the vector equation DB, okay, so I will write it out. R equals to passing point. Which is the passing point? B is the passing point of the line. D is also the passing point. So I am using the B for this case because of the X component is a 0. It might help us in solving the equation later easier. I don't know. This is how I feel, right? As long as I see there's a 0, usually it should be easier. Okay, then plus TP. What is the direction of the line? So the direction of the line is DB. Okay, the vector DB. So I will just put in -3, 15 and also 11. Alright, so I've got the first line. Then let's have a look for the second line. I want to form the vector equation for AC or CA also can. So let's find out the direction first. So the direction for the line is AC lah. Okay, so that means AO plus OC. So what's AO here? -2, -1 and also a 3 plus OC. So what's the OC? OC by right should be -3, -2 and also 2. Then the direction that I get in this case is -5, -3 and also 5. Okay, then I want to form vector equation of AC. So what's the vector equation? R equals to passing point. So passing point here, you can use the point A or also the point C, like up to you. So for me, I'm using the point C. So -3, -2 and also the 2 plus TP. I don't want to use the T anymore because I have using the T just now, right? So I will use the S now, another letter. And then the direction of the line should be AC, which is -5, -3 and also the 5. Okay, so now I'm having two vector equation already. To get the intersection point, I should solve them simultaneously. If I compare them, what do I have here is I'll be having, so let's have a look, 0 minus 2t, 4 plus 15t, then 1 plus 11t equals to -3 minus 5t, -2 minus, it shouldn't be a t here, right? It should be a s here. Then -2 minus 3s, and then 2 plus 5s. Okay, so the same rule applies. You need to find out the s, the value of the s, or the value of the t, okay, to get the vector or the point P, the position vector of the point P. Okay, when you equate them, right? When you equate them, basically, if you successfully solve them, you will get a position vector for the intersection point. Okay, so you just need to use any of the two equation here. Either two, any of the two here. Do we still have any space here? Yeah. Okay, so for me, I will be using the first equation and also the second equation to solve them simultaneously. Alright, so let me copy this solution into the next page. Okay, so so let's have a look. Continue from here. Then I copy it here so that it's easier for you to refer. Alright, so I want to solve the equation simultaneously. So I will let my first equation from this one. Okay, so negative 2t is equals to negative 3 minus 5s. Okay, I think I made a class mistake, is it? In my solution here is actually negative 3. Let me have a look. Is it a negative 2? Oh, it is a negative 3. Sorry, here. Can you see that? So that means I have made a careless mistake on this part. It should be 0 minus 3t. Yeah. Okay. So let's continue from here. Then this one is 0 minus 3t. Okay. Then after that, this part also is negative 3t. Okay. So I'm having negative 3t equals to negative 3 minus 5s. Therefore, the t is 1 over 3. Then 3 plus 5s. And this is the first equation. Okay. After that, I want to use the second equation. So 4 plus 15t is equals to negative 2 minus 3s. And what do we have here? I will make it as a second equation. Then I just sub 1 into 2. When I sub the first equation into the second one, I will be having 4 plus 15. The t is 3 plus 5s divided by 3. And then equals to negative 2 minus 3s. Right, so if you try to continue to solve this particular equation, okay, eventually when you try to simplify, you will have 28s equals to negative 21. And after that, the value of the s is actually negative 3 over 4. Okay, then once I get the value for the s, right, I no need to go back to find the t anymore, because no matter I substitute s into the equation here, the vector equation here, or I substitute the t into this vector equation, by right the answer should be the same because they intersect at the same point. So it is not needed for us to go and find out the value for t anymore. Right, so I will just directly substitute s value into the vector equation so that I can get the position vector of the intersection point. Right, so let's continue from there. Okay, so what is the value for OP? Position vector of OP. Okay, so I'm having negative 3, negative 5s. Then I'm having negative 2, negative 3s. And next one is 2 plus 5s. Okay, then let's try to simplify it. By right, you'll be having 3 over 4, 1 over 4, and negative 7 over 4. You can keep your answer in the column vector form, or if you want, you can make it become the ijk form, where it should be 3 over 4i plus 1 over 4j, then minus 7 over 4k. Right, so this is what we have for our part B. Right, then let's continue further for part C. Use a scalar product, calculate the angle ABC. Alright, so I don't know how the ABC look like, I just simply label it, right? So let's say this is our line here, A, B, and C. So this is the angle. We are interested to find the data here. To find the angle ABC, right, we have to apply scalar product. And in the scalar product, actually it involves the vector. Okay, so when you are using the vector, you have to make sure that the vector that you are using, right, are both going out from the point at the angle. So like for this case, the theta is at the point B, right? So when you want to apply the scalar product, please make sure that you are using the vector that's both going out. That means you have to use the vector BA and also the BC. So the general formula for this one would be BA dot BC dot product with BC equals to modulus of BA modulus of BC then cos theta. So this is the general formula that we are going to use for this particular case here, alright? So of course, first of all, I need to find out BA first. Okay, so from BA, right, we have actually find out the BA in the first part, in the part A. And I directly write the value, which is 2, -3, and also -4. Okay, after that, I need BC. So BC, again, you have to carry out the addition of the vector, where it should be BO plus OC. So BO is 0, -4, -1, plus OC. So where's the OC here? -3, -2, and also the 2. Then equals to BC. So BC will be -3, -6, and also 1. Okay, so once I successfully get the vector that I need in this part, then we'll continue, we'll start the calculation here. Alright, so according to the formula, right, it's BA dot BC. So BA dot BC okay, then let's put in the modulus of BA. Modulus of BA will be 2 square plus -3 square plus -4 square. Then multiply with the modulus of BC, which is -3 square plus -6 square plus 1 square with cos theta. Okay, so dot product means that you multiply x component with the x component, y with y, z with z, and then you add them together. Right, so 2 times -3, you get -6. -3 times -6, you have positive 18, and you add them together. Then -4 times 1, you have -4, and you add them together. Then on the right hand side, I will be having square root 29, square root 46, then cos theta. Okay, so before I can get the value of the cos theta, I simplify all the value first. Right hand side is a 8, then I bring the square root over, become square root 29 and 46 as a denominator. Then to get the value for the theta, you are taking cos inverse. So 8 divided by square root 29 and also square root 46. Okay, so if you didn't do any careless mistake, right? So by right, you should get this as the answer. In this question, they didn't mention whether we want to have the answer in terms of angle, in degree, or in terms of radian, right? So both are accepted. So for me, I put my answer in terms of degree. Okay, so this is how we solve question number 9. So let's discuss question number 10. There's a balloon in the shape of sphere. Okay, we are having a sphere shape with the volume V and also the radius R. Air is pumped into the balloon at a constant rate of 40 pi. Okay, so for this particular phrase here, air is pumped into the balloon at a constant rate of 40 pi, starting at t equals to 0. Okay, so you see the keyword rate. When we are having anything about the rate, right, it is actually the change of rate. So when we are having the change of rate, basically we are having something over dt, over the time. Alright, and for this particular phrase here, they are talking about the air is pumped into the balloon. So how we actually measure the air? So the air is actually in volume, right? So we are going to have dv over dt, and it is at a constant rate of 40 pi. So you're having a 40 pi. When you are pumping in the air into the balloon, right? So the volume of the air is increasing. Therefore, the 40 pi here should be a positive 40 pi. Okay? And after that, at the same time, the air begins to flow out, okay, of the balloon at a rate of 0.8 pi r. So flow out means that the volume is decreasing at a rate also. So when the volume is decreasing, so we have to minus the decreasing volume, which is 0.8 pi r. Alright, so this is how we get the equation for dv over dt. Then now what they say is the balloon remains at a sphere at all times. So show that r and t satisfy this differential equation. Okay, so from the paragraph or the question we have, right, we are getting this dv over dt. But in our question for part A, they want us to show the differential equation, which is dr over dt. So you can say this is dv over dt, this is dr over dt. So we should try a way to link them together. Right, so what is the, how should we link the v which is the volume, and also the r, which is the radius, when we are having a sphere. Okay, so here we can try to consider the general formula for the volume of a sphere. So what should it be? It should be actually 4 over 3 pi r cubed. Right. Okay, so for here, right, I will strongly suggest, if let's say before you go into the exam hall, I will strongly suggest you to go through again all the volume formula and also the surface area formula for all the possible shapes and also the polygons, okay, or maybe the prism, whatsoever, right? So you better go through with all the formula first before you go into the exam hall, because I didn't see any formula is provided here. Okay, but if I'm not mistaken, in our formula booklet, actually they did provide us with some of the formula here. Oh, this here actually. Yeah. So these are a few measurement. Okay, these are a few formulas that is provided in the formula booklet. But for the rest, right, if can, you try to go through it again before you go into the exam hall. Alright, so this is a small suggestion, right? Okay, so since we know that the volume of sphere is this formula, so how can we get the differentiation of V over R, dV over dr? So to differentiate this particular equation, I'm having 4 over 3. Pull the power in front for the R, I'm having 3. Then pi R, then the square, power minus 1. So if you try to simplify, you will be having 4 pi R squared. So this is how I get my dV over dr. And then to prove the equation, the differential equation that the question wants us to prove, what we can do is that we try to think about dr over dt. How can I get the dr over dt? How can I get this differential equation? By right, it should be dr over something multiplied with something over dt. And the something that we should use here, because in the question they did provide us with dv over dt, right? So by right, it should be dr over dv multiplied with dv over dt. Okay? And that's the reason also why I try to find out the dv dr, because I want to substitute here in the chain rule formula. Alright, so now let's start. dr over dt, I got dv over dr. So what I need to do is I have to take 1 over, so 1 over 4 pi r squared. Okay, then multiply with dv over dt. So the dv over dt that we have is this one, 40 pi. Okay, so minus 0.8 pi r. Right, then now let us have a look how should we simplify my equation so that it becomes something like this. So you won't see any pi in the equation, right? So that means I need to think a way to cancel off the pi. Maybe for me, I can factorize out the 0.8, the smaller number, and also the pi. When I try to factorize out the 0.8, right, at the part of the 40, what I get is 50. Because 50 times 0.8, I get 40. Then minus the r. So I think it's quite obvious now. The pi and pi can be simplified. 0.8 divided by 4. So you try to take 0.8 and divided by 4. So from there, I think you should get a 1 over 5. So simplify and rephrase everything. I'm having 50 minus r divided by 5r squared. Okay, so this is how we get the differential equation that they want us to show. Right, yeah, so this is what we have that. Okay, so let's continue to part B. Find the quotient and remainder when 5r is divided by 50 minus r. So to get the quotient and remainder, what I want to do is I try to use a long division. There are many ways that you can find the quotient and remainder, yeah. You can use the comparison method also if you want. For me, I still prefer the long division here. I'm having 5r squared. Then I want to divide it by using negative r plus 50. Okay, so first term, something multiply with negative r to get 5r squared. So the something here should be negative 5r, right? So negative 5r multiply with negative r, I'm having 5r squared. Then negative 5r multiply with 50. So I'm having negative 250r. So there's nothing here on top, right? So you can write as a 0r here. So try to continue the division, the long division. 0 minus negative 250. 0 minus negative 250, you should get positive 250r. Plus 0. Then now you ask yourself again, something multiply with negative r to get 250r. So the something here should be negative 250. So we get negative 250 multiply with negative r, then I have 250r. Okay, then negative 250 multiply with positive 50, I'm having negative 12500. Okay, then after that minus again 250 minus 250, you get a 0. Then 0 minus negative 12500, so you're having 12,500. Okay, so if you are trying to use a long division, right, you should know that this particular phrase on top is actually the quotient. And then this particular value at the bottom here is actually the remainder. Okay, so for me, I would prefer to write out again. So what is the quotient that I get from this part? So the quotient is basically negative 5r minus 250. Then how about the remainder? So the remainder here should be (12500). Okay, so I just try to state clearly what is the quotient and also the remainder that I get. This is what we have for the part B. Then let's continue to part C. For part C, they want us to solve the differential equation in part A, obtaining an expression for t in terms of r. Okay, so I rewrite again, yeah, what is the differential equation that I get in part A? So I'm having dr over dt equals to 50 minus r divided by 5r squared. Okay, so to solve the differential equation, I need to separate the variable to different sides. So that means I'm having two variables here. I'm having the r and I'm having the t, right? dt is a t. So I want to group all the r on the left. So I have to move all the r variable to one side with dr. Then I want to move dt to the other side. By right, this is a 1. Okay. So after you successfully separate the variable to each side, then you try to put the integration sign. Sorry, this one should be the dr, yeah? Okay. Alright, so integrate this part should be no problem. Integrate the 1, you should get a t here, right, on the right. But now let us have a look for this one. How can we integrate it? So again, in part number B, we have tried to figure out the quotient and remainder when I'm taking 5r squared minus divided by 50 minus r. So you can see this is actually 5r squared divided by 50 minus r, right? Okay. So how can I write out the expression, right, in the polynomial in the formula form? So by right, if let's say 5r squared is your polynomial, when you divide it by a divisor, okay, so equals to, it should be actually quotient plus remainder divided by divisor. Recall. Okay, so this is one of the important formula that you need to know. So polynomial divided by divisor basically is quotient plus remainder over divisor. So I want to apply this particular formula on this part. So according to the second part, part B that we get just now, our quotient, what's the quotient in second part in part B? It is actually negative 5r minus 250. Okay, then plus remainder over the divisor. So my remainder is actually 12500. What's my divisor? My divisor is basically 50 minus r. And it is equals to integration of 1 dt. Okay, alright, so let's have a look whether can we integrate every single term here. I can integrate this one in a very direct way. Negative 250 also can. Integrate this one by right should have something with the ln. Then integrate a 1 is a straightforward integration, right? Yeah, so it should be no problem for here to start the integration now. So I'm having negative 5 over 2r squared power plus 1, then divided by the new power. Integrate a constant, you need to add the r at the back, multiply with the r at the back, then plus 12500 is a constant, I just copy. I want to integrate 1 over 50 minus r. Integrate 1 over 50 minus r, you have ln, then 50 minus r. Differentiate the thing. inside the bracket, which is 50 minus r. Differentiate the thing inside the bracket, which is 50 minus r. If you differentiate this one, you have -1. So I have to divide by -1. And please note on this one, there are a lot of students, they will always forget about this division here, divided by -1 here. Then equals to integrate 1, you get a t, and then plus c. Alright, so next step, I want to try and get the constant c. In the question, they did provide us with an initial value. When t is equals to 0, we are given that r is also equals to 0. Okay, so if you substitute into the equation, the general solution that we get on top here, this is the general solution, right? Substitute t equals to 0 and also r equals to 0. By right, you will have c equals to -12500 ln 50. Okay, then after that, they want us to rephrase our answer t in terms of c. So I rewrite my equation again. So I'm having -5/2 r squared minus 250r, then plus, this is minus, right? If I simplify, I should have -12500 ln 50 minus r. For the c here, I get a negative value, and if I want to move it over, it will become positive. So I'm having positive 12500 ln 50. Okay, so if you want, you can keep your answer in this way or in this form. If you don't want, then of course you can further simplify it by combining the ln together. Okay, so I'm having positive 12500. Then I will have ln 50 minus ln 50 minus r. At this step, I will want to combine the ln function together into a single ln. How can I combine them? Okay, so basically what I want to do is like, I want to use the property. Last time we learned, right? We are having ln A divided by B. Ln A divided by B equals to ln A minus ln B. So now I want to do it backward. I want to apply it in backward. So I'm having ln A minus ln B. I want to combine it, become ln A divided by B. So by right hand, this one, if I want to combine that, it will be ln, then 50 divided by 50 minus r. Okay, so this is my general solution for this differential equation after I solve it. Okay, yeah, so this is what we have for part C. Okay, so let's continue to part D. For part D, they said find the value of t when the radius of the balloon is 12. So radius of the balloon is 12 means when r equals to 12, they are asking you what is the value for the t. So I think this question is very, very straightforward also. Okay, so let us try to take our answer from part C here. So let's copy and paste it. Okay. Yeah. Where should I paste it? Then I move it inside. Yeah. Okay. So from this equation, right, they already tell you that r equals to 12. So I think it's quite simple where you try to substitute the r equals to 12 into your equation. So your t is basically equals to -360. You take 12 squared times 5 divided by 2. So this is the answer. Then negative 250 times 12. So you should have -3000. Then plus 12500 ln 50 divided by 38. Then use calculator to help a little bit. So by right, you should have the answer 70 point something. So when you try to round it off to 3 significant figure, it should be 70.5. So this question, the T is talking about time, right? So if let's say you want to know about the unit, you can go through the question one more time and see what is the unit in this question. So you can actually observe that they didn't give us any unit about the time in this question. So you just keep it in this way where it is 70.5. Alright, yeah, so this is how we solve question number 10. Alright, so this is the last question for this paper. Question number 11. Okay, so we are given a rational function, and then they want us to find the f prime x and also find the exact coordinate, highlight the keyword exact, of the stationary point of the curve with equation of y. Okay, so stationary point. Stationary point means that basically you have to apply dy dx equal to 0, or f prime x equals to 0 lah. Okay. Alright, so for this equation, because it is basically a fraction, right? It is like a rational function. So you have something like a fraction. Therefore, when I want to differentiate any expression with this pattern, I want to apply quotient rule here. So the general formula for a quotient rule is you square the denominator, copy the denominator, differentiate the top. Okay, so I'm having, okay, so v square, copy the bottom, differentiate the top, which is du over dx, then minus, you copy the top, differentiate the bottom, which is dv over dx. This formula is provided in the formula booklet, so in case you can't remember, you can always refer back to the formula booklet. Alright, so let us start. I'm having this particular function, which is 2e2x divided by e2x minus 3e power x plus 2. Okay, so let's find out the differentiation here. Okay, so first of all, you have to square the denominator, right? Square it. Then I copy the denominator first. Then I differentiate the top. Differentiate the top means differentiate 2e2x. So differentiate 2e2x is, you by right lah, you should copy the 2. Differentiate the e power 2x, you should copy back e power 2x. Then differentiate the power. Differentiate the power, you get a 2 also, right? So multiply the 2 in front. So you're having 4e2x. Okay, then minus, and now you try to copy the top, which is 2e2x, and differentiate the bottom. Differentiate e power 2x, you will have 2e2x. Differentiate negative 3ex, you still have negative 3ex. Then differentiate a number 2, you get a 0. Okay, so this is what we get after the differentiation. And it looks like very complicated, so let's have a look and see whether we're able to simplify or not. So I don't do anything with the denominator first. So I want to have a look for the numerator on top, yeah. Okay, if I try to simplify, right, maybe I multiply 4e2x into every single term here. 4e2x multiplied with e2x, that means power plus the power plus power. So 2x plus 2x, we get 4x. Okay, then 4e2x multiplied with negative 3ex, so you're having negative 12. E, then power plus power, x plus 2x, you get 3x here. Then plus 4 times 2 is 8, then e 2x. Then for the second term here also the same, you're having negative 4, e 4x. Then 3 times 2 is a positive 6 now, then 6 e 3x. Okay, then seems like we can still further simplify them. Okay, so 4e4x and 4e4x can be simplified, right? And then I still have 8e2x minus negative 12 plus 6. So I'm having negative 6e3x. Then divided by what I have here is the denominator. Okay, then after that, I need to find out the stationary point, right? I have to let the differentiation equals to 0. So when I let differentiation equals to 0, this denominator move up, multiply with 0, it is still a 0. So my equation will become 8e2x minus 6e3x. Then let us try to solve this equation here. Okay, I can factorize out the 2 and also e power 2x. Then by right, I should be having 4 here. Then minus 3 e power x. Okay, so 2e 2x cannot be solved. Equals to 0 cannot be solved. So you have to ignore it. If you don't believe, then you can try to take ln both sides, right? Okay, take ln both sides. Ln 0 will be a math error. Right, then I'm having this part where 4 minus 3ex equals to 0. So you're having e power x equals to 4 over 3. Then we are trying to take ln both sides. So if you take ln both sides, ln e will give you a 1. So you put the power in front. Then the right hand side will be ln 4 over 3. So for this question, I think they asked us to keep the answer in the exact form, right? So I will just keep it into the ln form like this. So x is basically 4 over 3. Then if you revise the question one more time, they are saying about the exact coordinates. Coordinate means that you need the both x and y coordinate. I successfully found the x coordinate already, and now I want to find the y coordinate. So how can I find the y coordinate here? So to get the y coordinate, you substitute inside the equation of y, or the function fx. So it should be 2e 2x. So you substitute 4 over 3 here, the x as ln 4 over 3. If you bring the 2 over, okay, so you'll be having 4 over 3 square. 4 over 3 square will give you 16 over 9. So when you're having e ln 16 over 9, it will give you the value 16 over 9. Okay, alright, yeah, so this is how we simplify the particular term here. Alright, so I'm not going to show you the detail, so I will just directly write 16 over 9. Okay, then divided by, what do I have at the bottom part here? At the bottom part, y coordinate, by right it should be e, then 2x minus 3e power x plus 2. So the same thing happened here. E power 2x, I will be having e to ln 4 over 3 originally. After that, I will be having e ln 4 over 3 square. Then I will be having e, then 4 square is 16 over 9. So e ln anything, you will get back the value. So e power 2x, to me, it is still 16 over 9. Okay, then after that, what happened to e power x? So when you're having e ln 4 over 3, value is actually 4 over 3. Okay, so I will substitute this one as 4 over 3 here. Plus 2. Okay, so try to simplify this particular value. You should have negative 16. Okay, so this is how we get a y coordinate, and let's rephrase the answer again. So I will also show in the exam, in the solution, where the stationary point is basically ln 4 over 3 with y coordinate negative 16. So this is how we get the stationary point. Alright, let's continue to part B. Okay, so for part B, use the substitution of u equals to e power x and also partial fraction to find exact value of this whole thing. Okay, give your answer in ln a, where a is a rational number in its simplest form. Okay, so for this question, there are a few important words here. The first one is they already tell you clearly that you have to use the technique of substitution in integration. Besides the substitution, you might need to involve the partial fraction also to get the solution. Alright, and your final solution must be in exact value form. So I think everything is quite clear. Alright, so we'll start with the substitution first. Every time when they tell you that you want to use substitution for integration, you start with the substitution equation that is provided in the question first, where u is equals to e power x. So first step, let us try to find out the differentiation. So du over dx is e power x, and 1 over e power x will be equals to dx. Okay, so it can be also written as 1 over u du equals to dx. Because here it is very clear that u is e power x, right? So I can substitute e power x by using the u. So my dx is equals to 1 over u du. Why I need to rephrase it in this way? Because of later I want to substitute this equation into my part of the solution. Okay, alright, so once you get the differentiation from the equation of u equals to e power x, next we also have to change the limit here. All the limit here is basically the x equals to ln 5 and also x equals to ln 3. I need to get the value into the u because my aim is to change everything in x become u before the integration. Okay, so these are all the value of x, right? I have to change it become u. So you can just write it out in this way. When x is equals to ln 5, what happened to the value of the u? So u equals to e ln 5. You press calculator and see, the calculator will give you a value of 5. Okay, then when x is equals to ln 3, also very straightforward, your u will be equals to e power ln 3. So the answer is basically 3. Alright, yeah. And then after that, let us continue with the substitution. They want us to integrate this particular part here. I'm having integration of ln 3 to ln 5. The function fx is given. So what's my function fx originally? It is 2e2x divided by e power 2x minus 3e power x plus 2, then dx. Okay, so I want to slowly change it, become everything with the u. Okay, so let's have a look here. Ln 5 and ln 3, I will make it become 5 and 3. This is the u value, right? Okay, then after that, what happened to the term inside? Okay, 2e2x, 2 is a constant I just copied. E power 2x can be written as e power x squared. E power x is basically u in our substitution here. Can see very clearly, right? So e power x is the u, so you're having a u squared here. So by right, you should be having 2u squared. Same thing happened for the e power x at the bottom here. You will be having u squared. Negative 3e power x, it is 3u. Then plus 2, nothing to do with the number, so you just copy it as a plus 2. Then how can I get the dx here? So dx is basically equals to 1 over u du. So I will put it as 1 over u, then du. The part now, you can see that I have successfully changed all the variable in x, become something with the u. Okay, yeah. Then after that, let us continue further and see how can we integrate this particular phrase. There's a u here, I can simplify it with the 2u on top. So now, what do I have here is I want to integrate this one. I'm having 2u. It is a fraction, right? And for this fraction, it is not the f prime x over fx pattern. But I realized that I can try to factorize my equation or expression at the bottom. Okay, so this is after the factorization of the denominator, I realized that it is basically a rational function. So to integrate the irrational function, right, you should always try to think about something like how to integrate 1 over ax plus b, or how to integrate 1 over ax plus b with the power n, or maybe how are we going to integrate f prime x over fx. So for this question, right, I think we need to separate into a smaller bracket first, which is the partial fraction. So that's why the question also did actually hit this. Alright, you have to use the partial fraction to complete the question. Alright, so that means for this particular phrase, I want to apply my partial fraction. So let's start. Okay, so maybe I use the blue color so that you're aware. Okay, so I'm having 2u divided by u minus 2, u minus 1. I want to separate into two partial fractions, which is a over u minus 2 plus b over u minus 1. Okay, I want to get rid of the denominator, so I multiply the whole equation with the original denominator. Okay, so multiply u minus 2 and u minus 1 at this particular part here, so you'll be having A multiplied with U minus 1, because U minus 2 and U minus 2 has been cancelled off. Okay, then for the B here, okay, so you bring up this one. So U minus 1 divided by U minus 1 cancel off. You're having B with U minus 2. Okay, then I want to try and get the value for A and B. You can compare them. You can expand and compare, or you can use any method that you like. For me, I try to get rid of the A first. If I want to get rid of the A, right, I have to let U equals to 1. Because if I let U equals to 1, then 1 minus 1 becomes 0. I can easily get the value for B and for the B. Okay, so when let U equals to 1, substitute 1 into the U here, you're having a 2. 1 minus 1 becomes a 0. Then 1 minus 2 is a negative 1, so you're having negative B. Therefore, your B is actually negative 2. Okay, after that, for the value of A, I will let U equals to 2, because I know that 2 minus 2 is a 0, the B will disappear, and I can get the value of A easily. When U is equals to 2, 2 times 2, you get a 4. Then 2 minus 1 here, you get a 1. 1 times A is A. So your A is 4. Okay, so from here you can see that I already get the partial fraction here, which is 4 over U minus 2, then minus 2 over U minus 1. Alright, and this is my partial fraction. Therefore, I can continue my integration here, where I need to integrate the partial fraction. Okay, so I'm having 4 over U minus 2 minus 2 over U minus 1. Okay, then 4 is a constant. If I integrate 1 over U minus 2, I will be having U minus 2. Negative 2 is a constant, I just copy. If I integrate 1 over U minus 1, I have ln U minus 1. And of course, I have to substitute in the value 5 and 3. Okay, so substitute in the value very carefully. So 5 minus 2, I get a 3. 5 minus 1, I get a 4. Then substitute 3 now. 3 minus 2, I get a 1. 3 minus 1, I get a 2. Okay, then after that, for this question, right, you have to simplify all the terms with the ln here. And then you have to apply the properties of ln, of course. And let's have a look for the question again. Our final answer is in the form of ln, a single value. And this value is a rational number. Okay, ln A. So that means I have to try to group all the ln together, become a single ln with a number A. So before I can group them together, what I need to do is that I will bring back all the number in front to make it become the power. So like this one, you're having 3 power 4. This one, you'll be having 4 power 2. Okay, then ln 1 is a 0. This one is a 0. Then this power also, you bring it back, become ln 2 square. Ln 2, 2, okay, ln 2 power 2. So ln 3 power 4, you'll be having 81. Ln 4 square, you'll be having 16. Ln 1 is a 0, right? No need to include it. So ln 2 square is a ln 4. Okay, so how can I group all these together in a single ln? When you're having a positive, means that the number multiply with each other. So you're having 81 multiplied with 4. When you're having a negative sign in front of the ln, that means it's divide. So you're having a divided, you need to divide by 16. So simplify from this part, by right, you'll be having ln 81 over 4. So this is the pattern of the answer where it is actually ln A, and A is a rational number in the simplest form. Okay, so this is how we solve this question number 11. And thank you very much for watching the video. If let's say you found that the video is useful, please help me to share out this channel and ask your friend to subscribe to this channel. Thank you very much.